Welcome, ladies and gentlemen, to the group exhibit Hydrogen Fuel Cells and Batteries here to our public forum. The next 20 minutes we will talk with Stephan Rieke, who is right next to my side, Head of Sales of ETOGAS GmbH, about power to gas, hydrogen and synthetic natural gas, SNG. So we can all talk together. If you have any questions, just raise your hand. I'll be with a microphone right with you and you can participate in this talk. Mr. Rieke, when I prepared this talk, I was wondering, why did you change your job? You were at Solar Fuel GmbH, as far as I knew. But then I found out you didn't change your job, did you?
No, we didn't change, or I didn't change my job, because from the times when we were called Solar Fuel, every time the customers ask us, which product of solar energy will you sell? And we are not buying products for solar energy. We are an EPC company, engineering, procurement, construction company, and producing units for the production of hydrogen, electrolyzers. And if you have no hydrogen infrastructure available for your consumption area, then we can also add a methanation step to combine CO2 with hydrogen to methane, synthetic natural gas.
Synthetic. So it's all in your name, actually. It's E2GAS. So it's correctly pronounced, isn't it?
Yeah.
Because it's electricity goes to gas. Well, that's a big topic in Germany, especially right now. The German energy transformation has one big problem: the energy storage of volatile renewable resources, and you have the solution for that.
Yeah, we think one of these possible solutions might be one of these columns which we need in our building, might be a power-to-gas approach, because when you are curtailing the huge excesses of electricity, which we have especially in the northern part of Germany, we have over 50% of curtailment of wind turbine electricity operation mode, and instead of switching off these wind turbine electricity, we would propose, let us add in power to hydrogen or power to methane unit, and the vision would be, a text of vision is every time quite nice, every wind turbine will get a gas piping system. To what? In moments of wind electricity excess, we can let flow the electricity into this gas piping system by hydrogen or SNG or methane, and so you can get the huge amounts of available electricity during all of the year, if this is not needed inside our consumer sector. And that's the problem. This high volatile and dynamical profile of electricity production is not synchronous to our load profile. And we have a solution to curtail these amounts of electricity and to smooth this profile according a projectable, assured, renewable deliver profile.
And it's important to understand that, of course, renewable electricity should be used directly whenever possible, but there are some times where there's a surplus of electricity in the grid, especially at night. Nobody needs electricity at night, and you could easily produce hydrogen. You only need an electrolyzer and some water.
Yes, that's for sure the possibilities. You can produce this hydrogen in these cases where nobody can use these energy demands, and therefore the possibility of hydrogen or methane as in an own infrastructure, or perhaps the injection of hydrogen into the natural gas grid or synthetic methane in case you have high restrictions for the hydrogen injection, then we can add the gas piping system with this huge grid capabilities and storage capabilities of more than 3 or 4 months.
You mean an own hydrogen grid?
You can do it in your own hydrogen grid if you have this, or the existing natural gas piping system as well.
But if I think of a hydrogen grid, we had to build a new.
Yeah.
Yeah. Okay.
Yeah.
Is it worth it?
Time and money are normally predicting a little bit these problems. That if you have to invest in an own hydrogen grid, I would say I would not survive this existence. Therefore, the idea was to use the existing natural gas grid system as an existing asset. We have over 500,000 kilometers of piping system. And just to give you an example, a piping system with 1.2 meter diameter can transport more than 30 gigawatt of power from the north to the south, from east to the west. And this is existing. You don't see this piping system. And we have an additional element as our gas infrastructure with natural gas, the storage system as underground caverns, subground systems, which can facilitate an energy autonomy range of more than 3 or 4 months. And if we have no renewable electricity available in winter, no wind, no PV power possible, then we can rely on an existing natural gas storage system and can supply the existing gas to power, for example, power stations to supply electricity in case of non-existing electricity.
So you say we could just put the hydrogen from electrolyzers by surplus renewable energy into the gas grid, but isn't that downgrading the hydrogen?
It might be downgrading from the hydrogen, but in case you have no other opportunity because of costs, investment, or opportunities, then don't or not to use these energy streams would be worse. Therefore, we are every time arguing both solutions. If you can use the hydrogen, do this for sure. That would be better. But if you have not the possibilities and not the investment capabilities to accomplish all of the requirements, you can use the natural gas grid. These are options.
Okay. The natural gas grid is a little bit of a problem because some say, well, we could put like 10 volume percent of hydrogen into it. Others say only 5%. I know the automobile companies say 2% maximum. What is right?
The reality normally forces you to check and to investigate in detail analysis what is the concrete hydrogen restriction for the injection. Normally, the guys from the natural gas industry says 5 or 10% in general. But for sure, if you have on your gas piping system looking to the consumer, you have sensitive consumers, like a filling station for natural gas vehicles, then you can only add up to 2% of hydrogen. If you have gas turbines or, for example, special subground storage caverns or aquifers or mediums, then you also have to limit your hydrogen amount. And this has to be taken into account in your special project character of every hydrogen production.
And you don't want to live near a hydrogen injection place because it has another volume and you pay much more for less energy if you have a lot of hydrogen on your bill, isn't it?
The accounting or measurement of hydrogen on your existing natural gas measurement tools as well is a quite interesting tool or question. And all of these questions have to be examined in all of these possible projects. But for sure, you can inject hydrogen, but you have to check this in detail. Mm-hmm.
But maybe even better would be to methanize the hydrogen with CO2 from, let's say, biogas plants, what you already do. The good thing about the methanation process, it's exothermic, so you can even use the heat.
Yeah. We won't give up the heat which is occurring during the step of hydrogen to methane. You will lose theoretically up to 17%. And we can produce, with this exothermal heat losses, we can produce steam up to 300 Celsius degrees, 70 bar. So also in our project, for example, in the Audi case here in the northwestern part of Germany, where we have linked a power-to-gas plant with 6 megawatt with an existing biogas plant, the heat utilization concept every time is designed to combine gas and heat, which means power-to-gas, with an existing heat demand. like a biogas plant is a heat demand.
Yeah. You need the biogas plant for the CO2, and the biogas plant needs the heat. It's a perfect match, probably. And what you do is then a gas heat cogeneration, we could say.
Yeah, that's a heat and gas cogeneration, like the cogeneration of electricity and heat. And so we want to use the most of the 100% of electricity inside 60% would be led to the gas fraction, and roughly 40% is occurring on a low and high temperature level. And this heat we want to use. And this is what we have done in these Audi case.
We're going to talk about this Audi case in Werther, of course. Just in general speaking, do you think this power-to-gas industry will grow within the next 5 years, we could say, or will it take another 10 years, maybe 20?
That depends not on the technical issues or solutions. I think that all of these guys which are here showing you your industrial applications would say the market from the point of technical realization is available and existing. But what is still missing, and the lack of the necessary legal conditions to add, for example, between the electricity grid and the natural gas grid, power-to-gas plant is functioning like a chemical transformer unit. And at the moment, these transformer units are charged by fees. And this is not, let me say, the correct adjustment inside our legal system, because not only the Audi guys, all of our possible customers, they are seeking business models. And at the moment, if somebody has to pay for electricity, which is injected into the natural gas grid with its official character as well, then this is not a so-called end consumer. But at the moment, it is viewed and it is punished by legal fees.
Yeah, that's a big obstacle to come over. I hope and I believe that the politicians have seen that problem already, but until we get it solved, this could take a little bit of time. But there's another problem, I think. The problem could be cost for electrolyzers. You say alkaline is best.
Yeah, we are convinced that we are running a material bed. The alkaline system, which is also possible to run it dynamically and very intermittently. We've done this 25 years ago in a high solar project in Stuttgart as well with PV power, with its most dynamical challenges, I would say. And alkaline is based on cheap nickel and cheap plastic materials. And now you can imagine if we would run the market in gigawatt scale, multi-gigawatt scale, then of course everybody of us here on this fair is running a material bed, platinum iridium with naphthalene and titanium versus nickel and plastic. And then you can make your own bed what will function in the future.
We should have one from the PEM side here.
Yeah, for sure, for sure.
That you had an elevator pitch yesterday, and there were 10 different electrolyzer manufacturers arguing which one is better. But one disadvantage of alkaline, as far as I know, is it needs a lot of space. That's true, isn't it?
For sure, we have larger surfaces because we are running and operating our systems on lower current densities. Therefore, we need much more surface, but surface is not the cost impact on a concrete real system. Our advantage could be, for example, the cost of capex, because in an alkaline system in 10 or 20 megawatt range is capable for 500 euro per kilowatt to be installed. And also the maturity of the system in multi-megawatt scale now is available on the market, beside the possible efficiency in your special case of a total plant. Not only the cell characteristic, you have to view the whole output of a complete device, and then you will see the specific energy efficiency of such an alkaline system is not the baddest one.
Are there any questions from your side? Just raise your hand. I'll be with the microphone right with you. That's not the case at the moment. So you can deliver turnkey systems for power to gas or power to SNG with 1.2 megawatt electrical input power already, and it's scalable.
It is scalable. 1.2 megawatt power is our smallest unit to start with these units, because every technical device has a problem of fixed cost. And therefore, we've started with 1.2 megawatt, but for sure you can modularize and scale it up according to your needs, the project character, the availability of electricity, the power purchase concept, which we are developing together with customers, one of the basic threats in every project for a business case. And so to modularize and scale up your plans according the business case, like power purchase, and the possible price for renewable hydrogen or renewable SNG. That's the basic characteristic in all of these projects, which we are doing in a cooperation project according our consulting capabilities, which we are also offering.
Let's touch a little bit the Audi project that you have realized already, a 6.3 megawatt input power on behalf of Audi in Werlte. What was the background of this project?
Yeah, in 2010, the guys from Audi came to us and said, oh, we have a small problem with CO2 emissions in the future.
They do have, yes.
And you know for sure, one of these OEMs in the automobile sector had made some software adaptations to solve this problem. But the Audi guys were convinced in 2010, hey, you guys, we've had only a 25 kilowatt plant. And now the Audi guys convinced us, you will order it by us with a plant which will be 240 times larger. And then we've built this plant. For sure, in 2013, we have finalized this project. And since these years, the Audi plant is now, let me say, operated by the TSO, Transmission Service Operator. It's TenneT in this zone. And TenneT is switching on or off this power-to-gas plant according to the balancing power needs or service balancing power levels, according to the needs of the electricity grid. And therefore, this plant for Audi is now offering balancing power in this quite interesting economical market for grid stability.
But for Audi, it is they did it to give an well, to give an answer to the recent electric car hype. To say, well, a CNG car could would run on virtual e-gas would be environmentally friendly as a pure electric vehicle that runs on wind power.
Yeah. The Audi message is, if you will drive long distance or you will have long distance autonomy, you can do this with a classical internal combustion engine based on a renewable fuel, in this case a renewable gas which is injected into the natural gas grid. And every customer for Audi A4 or A3 G-Tron is supplied by a special tank card system and is enabled to be charged by every one of these 900 existing gas filling stations. So you can run or operate your car 15,000 kilometers per year, for example, with renewable so-called e-gas. And if you will calculate also not only the well-to-wheel emissions or tailpipe emissions on your vehicle.
You have to see cradle to grave.
Yeah, the cradle to grave emissions. You have to account also the emissions for the production of the fuel. Where will come the energy or the electricity for this fuel? You have to calculate also the natural gas storage system, like the battery as well in this case. And if you will calculate all the so-called life cycle assessments emissions, then this so-called renewable gas from Audi is not worse than a classical battery electrical vehicle. That's quite interesting. With the difference with this e-gas vehicle based on natural gas, you can drive 500 kilometers only in this gas mode, an additional 500 kilometers in the gasoline mode if you want to do this.
Mr. Rieke, it was a pleasure talking to you. It was highly interesting, but we have to stop now because we run out of time. I would like to advise you to visit Mr. Rieke at his booth of ETOGAS just down the L at C58, and would like to thank you very much for this interesting talk. Thank you very much.
Thank you very much.
It was a pleasure. Just stay here in the public forum because our next interview will start in right 1 minute with Professor Dr. Gunther Kolb, Head of Division Energy and Chemistry Technology of Fraunhofer ICT IMM, about hydrogen generation from alcohol fuels through internal and external reforming.